All right, hello everyone. Thank you very much for tuning in to the second panel of the joint warfighting track of the Tradewin Member Showcase. Today we have J.R. Rodriguez and Brian Geisel with Geisel Software, Inc. And thank you guys once again for joining the session, and I will let them take it away with their presentation.
Thank you so much, Cole. I really appreciate it. And thank you everyone for joining our quick presentation. We're very conscious of the time limits here. So what we're going to do is show you, in effect, a quick slide deck. And let me make sure I'm sharing my screen. Can everyone see my screen? I hope. All right, so here we are. We are Geisel Software. And if there's only one word I can highlight on this slide, it is extraordinary. We are extraordinarily good at developing software, especially, as I'll get to the next slide, we're especially good at taking leading edge technology and putting in the software engineering, the skilled expertise of our software developers, architects, QA, QC people, and turning it into something that works. You know, I hear a lot about trust in AI and machine learning. You want to build trust? Make something that works right the first time. And what we do is exactly that. The bullets that you're seeing on the screen are just some of the many things we've gotten involved with in terms of taking leading edge technology, specifically AI, machine learning, and turning it into solutions that work. How do we do that? We do that by being able to provide all of the pieces of the puzzle depending on the particular solution. We'll write software right on bare metal. We'll do a mobile app to control the device. We'll do cloud-based apps to communicate and also control the device. We'll develop ironclad security around the entire solution to make sure that it's safe and secure. And we can do the QA, we can do testing, we can do all kinds of project management, getting it ready for manufacturing and actually getting out the door. We can go from concept all the way to finished product or anything in between. You know, when I'm asked sometimes by clients or prospects, do you folks have experience with this technology or that technology or this particular platform or this language? My stock answer after multiple years here with Geisel is more than likely. Let me just check and get back to you. I say that because I've never yet had to get back to a client or prospect and say we didn't have experience with a particular technology or platform. We have that many skilled, experienced developers that have done a wide variety of projects. That's also afforded us tremendous industry acumen. We're used to FDA compliance, ITAR, EAR, HIPAA, you name it. We've been involved with that type of regulation and compliance requirements. We're highly scalable. We can grow and shrink as the project needs. Our talent is top shelf, as is our leadership. You'll get some exposure to our CEO, Brian Geisel, in a minute. We are a GSA contract holder. We have multiple contracts with NASA. Brian will be talking about those. We do work with the VA. We're a subcontractor to the U.S. Army. We also have a ton of commercial clients for whom we do robotics, medical equipment, Internet of Things, a wide variety of different software solutions for a wide variety of clients and customers. I just really quickly want to talk to you about some of the case studies that Brian won't be talking to you about. Brian is going to dive in deep to some exciting AI machine learning case studies that we think will be very relevant to your needs. But I just want you to know that we've done a wide range of things. Like, for example, we partnered with Teledyne FLIR on an Army robot, and we developed the operator control interface on a tablet for it. With Safe Op Systems, the picture in the middle, we developed the prototype software for a device that as the fire trucks are heading out of the fire station, the drone takes off autonomously, flies to the fire, and starts circling it and videoing it so the firefighters can see what's going on with the fire before they even arrive. And the other exciting thing I wanted to tell you about is our relationship with Carbon Black. You probably have heard of Carbon Black. They are a premier anti-malware solution used by the largest data centers in the world. Their original software worked on Windows, and they had a major client that needed to put it on Linux. They don't know Linux so much, but they knew this. They knew that Geisel Software are security experts, cybersecurity experts, and we're also Linux experts. So they actually engaged us to create the Linux version of Carbon Black. So our security credentials are quite solid and quite deep. And with that, we want to get to the real meat of the presentation. I'm going to turn this over to Brian Geisel, where he's going to dive into some really interesting, exciting AI and machine learning projects that we've been involved with.
Thanks, JR. So just to give you an overview, I'm just gonna walk through some of the technologies that we've been developing, focusing on a few that I think might be relevant here, but there are others and more, and certainly plenty more depth in this. So just initially, we've won multiple SBIRs from NASA and also additional contracts beside the SBIRs for things in and around swarming technology and robotics, searching, mapping, localization, intent recognition. So I'm going to jump in and give you some of the English on some of those, what they could actually be used for, and what some of those technologies are. So the first one that I will talk about is swarming robotics. When we talk about swarming heterogeneous agents. Okay, what's that mean? All that really means is different kinds of robots. And maybe they're not even really robots. Maybe it's an autonomous cart that can deliver a thing from one place to another. Maybe it is a complete robot. Right? And so these are all systems that are working together to accomplish a task that either is in a place where we can't send humans, or as space is, we tend to like to test for extreme environments first. So the initial one is swarming, where it was used for search and mapping. And so search is pretty obvious on, we need to find the origin of something. We need to find the origin of a gas leak. And so we can work on determining where the source of that is and pinpoint the source of that. Or things like radiation, where we want to map an area around where inside this range is what's deadly to humans. And so we want to create a map of the area. And so we have some algorithms that do extremely precise detection for that, to be able to build a map of the area that is unsafe and or less safe, that kind of thing. And then I think the next one that we'll go on to talk about, if you want to flip me, JR, is part of making that real is knowing where each agent is in the system. And so in a generic sense, we use GPS for that. Well, in cases where GPS has been denied or hostilely blocked, or in cases like the moon or Mars where there is no GPS available, so you've got to be able to deal with your own localization, whether that's a cave, whether that's some sort of enemy that is preventing us from using GPS. And so we have some localization that works well in GPS denied environments. So in the original SBIR that we did with NASA, we did some work using computer vision to do some of this localization. And then we've gone on to add localization from ultra wideband, which actually ends up with a number of things where you're worried about the battery life on a drone. How long can this drone do its autonomous behavior? One of the nice things about ultra wideband is you can do the communications in the same band that you're using for the localization. And so you're saving power by by doing one thing and getting two benefits out of it. And so this localization, whether it's on the moon or Mars, or whether it's underwater, or whether it's somewhere else that we might not have access to GPS or it's been blocked, this is a system that, and in fact, NASA has said this is something that is super interesting to DoD. So we want to fund it, but we also see a lot of need at DoD for this. And then the other thing that I want to talk about is pretty prevalent throughout all of our work, because as we're working in places that we can't test, so whether that's deep undersea, whether that's on the moon, one of the things that we need to be able to do is simulation. And I might be getting myself out of order here, JR. If you want to jump to the next one, jump one more if you don't mind, and I'll go back to this one. So a realistic simulation is one of the things that is sort of like JR talked about security for us. We're working on so many things that need to be secure that we're not a security company, but we have to be anyway, because to do the kinds of things that we need to do in the environments we need to do them, and for the clients we need to do them for, we need to be a security company. We need to be constantly aware of that. And so one of the things that we're doing regularly is simulation. And so that simulation is for so many different pieces here. So one of the things, I've got some lists here of Gazebo, Unity, Unreal Engine. Gazebo tends to be for physics. If you want to know if you're going to get stuck in the mud, you want something like Gazebo. You might work some of that in MATLAB or something else. But you want an actual physics simulation so that you know how that thing is going to behave in the environment physically as it interacts with the other things. If you've ever played video games, first-person shooters, those kinds of things, they tend to use Unity or Unreal Engine as the engine behind those, where things look realistic. But if you're driving through the mud, maybe the Jeep is a little more squirrely, but that's it. It's not going to get stuck. It's not going to have physical properties of mud, that kind of thing. So we actually have expertise in both sides of that. So one of the things that NASA has need of is to be able to test things before they go to Mars. Imagine that. It's not so easy to just test on Mars. So we need to test in a simulator before we take it there. And one of the things that we regularly find ourselves in is with all of the new AI and machine learning technologies out there, one of the things that runs across all of those is that you've got to train them. So if you want to train them on how to drive, for example, in this example of this driving this Jeep, for example, if you wanted to train an AI how to drive that Jeep, you might need to drive that Jeep for thousands of years. Well, that's not really practical. Maybe you could get 100 drivers to drive it, but you still need them to drive for tens of years. It's still impractical. But in a simulation, we can do that driving. We can simulate it with real physical properties or real photorealistic properties as necessary, so that you see what's going to happen. And we can run that with compute time by throwing many, many computers at it. And we can run those thousands of years of training in hours or days, depending on the situation there, depending on the compute power that we put behind it. And so one of the things NASA had need of was to be able to do a photorealistic simulation. And JR, if you want to go ahead and play that video again there. So this is a little clip of a photorealistic simulation that we put together of Mars. And this is some of the early stages. It will continue to get better, but you can already see this looks a lot different than things you might see simulated in MATLAB or other places where you see that. So we do that side too, where you're simulating the physics. But here, if you actually look at these, we call this rock formation blueberries here. And so, just leave it right when it gets to the end there, JR, and we'll look. So what we're doing right now is this video is playing, and this would be a training program or a training simulation for a machine learning algorithm that's looking for interesting rock formations that might indicate life. And so as we're getting closer here, we're starting to see these blueberries on this rock to the right. Those are a rock formation, and obviously not real blueberries on Mars. And those rocks indicate that there was likely water here. And so those are the kinds of things NASA's looking for. Obviously, in different situations, we're looking to train the machine learning to look for different things. But we just wanted to give an example here of where we're able to use photorealism to actually train a computer vision system. And so we're able to greatly increase how fast we can train machine learning systems and even put AI and ML in places you couldn't have previously put them because there was no way to have thousands of years of simulation data. And then, sorry, JR, I did this out of order, but if you want to go back one slide for us. And then this is one of the other ones that we're doing here, which is intent perception. This intent is for one swarm to observe another swarm and determine their intent, or to communicate their intent by, for example, traveling a particular path. So the bottom right scenario would be, if I went the red path, this observer up in the upper left can't tell if I'm stopping at site B or going all the way over to site A. But if I go this longer way, then it's clear to everyone I'm definitely not going to site B. I'm definitely going all the way through to site A. And so, again, when we talk about autonomy and systems behaving on their own, then there are certain problems that we start to run into where people are way better at making certain decisions. And so how can we make the artificial intelligence better at making those decisions? And so this is one of those pieces where in cooperation, often you'll communicate between these swarms. This is a place where NASA commented that this is important and relevant to DoD. So this might be a place where a fleet of ships or submarines that we might detect, or traffic formations, or these kinds of things where we can observe what are they trying to do. Everything from we're the little robots and those are giant trucks and they're headed this way, they look like they're about to run us over, we should get out of the way, to that is a hostile fleet that is definitely making aggressive actions. We should report this aggressive action back. Or it's important enough we've determined within the swarm we should report this aggressive action back, and it's worth breaking radio silence to do that. Those kinds of things are what's inherent in the work that we've done in intent perception. And so with that, I think we're just about out of time. If you want to, Jared, do you want to close us out on comments and questions that anyone might have? I know we can't take questions here today.
Yeah, thank you, Brian. You know, if we were to leave you with one takeaway, it's that Geisel Software has a ton of experience, a ton of real relevant solutions and projects, but we're flexible. We'd love to hear what your needs are, perhaps collaborate on a statement of needs. We're open, we're flexible, we're highly skilled, and we happen to think we're a perfect fit for the Navy. And we hope you agree.
Great. Thank you both so very much for that presentation. That was fantastic. And I hope everyone in the audience enjoyed it as well. And we will find a way to get the contact info from the audience to you and vice versa. But thank you, everyone, for tuning into the session. And we hope to see you guys in the next one.
Thank
Thank
you.
you all. Appreciate it.
Take care.